And let's go ahead and take a look at the homework assignment that was due 3 minutes and 25 seconds ago. Now, if you read the instruction here, most of you already know that the trace has 3 worksheets that you have to trace. The sheets 2, 3, and 4. So those are the 3 test cases that you have to trace. And let's go ahead and take a look at the assignment. This is the algorithm. Sorry?
Are you recording right now?
I think so. I can double check. I can double check and see which program is receiving the input and it is correct. So right now it is recording from the right source. I forgot to do this last time with one of my classes. So the first 7 minutes, it's going to be a silent movie. It's like completely silent, and you can see the mouse pointer moving around and doing stuff, but there's no sound. All right. So this is the program, and we'll open. Well, first of all, let me save it first, because if I don't save it, it's read-only, and I cannot, make any changes when the file is read-only. I will save it to today's folder. So at the end of the class, if someone remember to remind me, I will upload all the files that I captured today, so this way you guys don't have to be busy copying everything on the whiteboard. But you do want to keep your own notes, because there are certain things that I talk about and I don't exactly write it down. So if there are anything like that, you should write it down on your own notes. And sometimes it's something that I do not say. Okay, I may not be saying anything, and you suddenly come to a realization. Oh, so that's what he meant, and that's the kind of stuff that you have to write down, because obviously it's not going to be captured on the whiteboard. Okay, so let's go ahead and trace sheet number 2. Where do we start?
The top.
The top. Very good. So whenever you trace a program, we always trace from top to bottom. In other words, even if there are multiple conditions, in this case that's not the case, but even if there are multiple conditions that are true at the same time, you still have to evaluate the conditions from top to bottom. We always start with line 1, and on line 1 in this case, it wants to evaluate the comparison. X is different from Y. Is that true?
True.
True. Very good. So that makes it very easy, because if the condition is true, we just go ahead and execute the statement associated with that particular condition. In this case, line 2 is the action to perform when X is different from Y. So we execute line 2, which updates Z to have a value of 1, and then we are done. Oops, post. Okay. Do we have any questions? Yep.
Is it wrong if you put the 2 and the 3 also into the answer?
The 3?
Well, if you just wrote all the numbers across, is that
X and Y?
Yes,
Yeah.
you can copy everything
Okay,
down.
okay.
That's fine.
Okay.
I'm just using the shorthand in the
Okay.
class, because otherwise it would take longer.
Right.
Yeah. It's okay if you want to copy everything. At some point, you will stop doing it because it's just way too tedious that way. Okay, this is the second test case. The second test case starts with X and Y being 1, X being 3, and Y being 2 to start with. So with this one, it is a little bit more tricky, because when you look at the condition on line 1, it is X is different from Y, which is true. But when you look at the condition on line 3, it is also true, because X is also greater than Y. Okay? But remember, you execute the code from top to bottom. So don't get distracted by line 3, because we are not starting with line 3. We're starting with line 1. Okay, so we start with line 1, and then line 1 says, okay, let's go ahead and evaluate, is X different from Y?
Yes.
The answer is true. Oh, okay. If the condition is true, then we go ahead and execute or perform the action associated with that action, which in this case is line 2 again. Z gets updated to 1 again, and the big question is, where do we go from here? We go to post right away. Okay? So this is quite important, because it tells you that when certain programs are written incorrectly, and things like this can happen. Now in this case, it is really, really bad, because can anyone say when line 4 will execute?
Never.
Never. Very good. So when you look at this as a multi-branch conditional statement, each arm or each action is a branch. Line 4 is what we call a dead branch because you never get there. Okay, it is there in the code. It seems like in some conditions it should execute, but in reality, you never get to that line to execute it. And this is one of those logical flaws in a program that are really hard to catch because one, it is not a syntax error. Okay, I'm not specifying it in the wrong syntax because if anything, syntax errors are the easiest to catch because the compiler or the interpreter, whatever language you use, like Perl, PHP, Python, C, C++, Java, they won't let you pass unless your program is syntactically correct. So I would not worry about syntax errors. On the other hand, logic errors cannot be caught by the compiler most of the time. And this is an easy one. Okay? This is an easy one because the expression or the condition is really short and they're very simple. If you have anything that is long, then you can end up with a dead branch and it is hard to catch that it is a dead branch. Okay? Now the other thing you have to be careful, now that we have talked about dead branches, is if I flip this condition with the first one and flip the actions accordingly, then it is no longer a dead branch. So that means the order of these conditions can also be very important. And just exercise caution when you specify multi-branch conditional statements and make sure that you know how the program is going to behave. Okay, so this is our third test case, which is the last one. And once again, we start execution from line 1, and it asks us, X is different from Y. Is it true or is it false?
False.
It's false, so we go to line 3. Line 3 asks, is X greater than Y? It is also false because they are the same. Then we go to line 5. Line 5 asks, are they the same? The answer is true. So we go to line 6. Line 6 is the action associated with the condition of line 5. And Z will get updated to 3, and we are done. So now here comes another question. We know that line 4 is a dead branch already. The question is, do we have any additional dead branches?
8, yes.
Line 8 is also a dead branch. How do we know line 8 is a dead branch? We will never get there because the two conditions on line 1 and the condition on line 5 will cover all possible cases. Okay, very good. So we might want to keep an eye on this particular algorithm because when we talk about pre and post conditions today, we will touch on this topic again. So I have already saved this file into today's folder. If I remember or someone reminds me to upload it, it will be on Moodle after the class. So that way you guys will have a copy of the answer as well. Let me do this before I forget. I always forget about the clerical stuff. So I will go ahead and ask it from here. We will continue today's lecture. There's no homework at this point, but I will give you a homework when I get back to the office. The reason I cannot give you a homework right now is because I don't know how much I can cover today and what would be a comfortable level of homework assignment for today. From last week's video recording, I think we are in nested statements, which is the very last item inside topic number 2. So we'll go ahead and cover nested statements now. We have already started on this topic, so it's not like new. It's just that it is. I have not finished yet, and I think we have started to talk about a more complex example when we ran out of time. So this is where we left off last time, and we'll be picking this up today. Last time I watched my own video clip, and we were talking about how do we count the number of statements, and the answer was some number that I cannot remember. But the most important part is to recognize line 5 to line 8 collectively is one statement. But inside that statement, we also have line 6 and line 7 as individual statement. In other words, you can look at line 6 and line 7, the assignment statements, as a file in a file system. But when you look at the while statement from line 5 to line 8, it is like a folder inside a file system. It is also an entry in the containing folder. So that's why when we counted line 5 to line 8 collectively is one statement as well. Do you guys still remember that discussion? Vaguely? Okay. If you don't have enough time to really go over everything that we talked about in the previous class, one trick is to just go over the last 5 minutes or so from the previous class, on your cell phone or on the computer, like the night before. So that kind of brings you back to the context of where we left off from last time. And I think having a video recording helps because you can also listen to that part of the lecture, the last 5 minutes. So that will just kind of bring your mind back to the right context for this class. And someone mentioned, coming here on the bus, so that will give you plenty of time. If your cell phone can watch YouTube, and some can, that will give you plenty of time to review the material on the bus. Now these days, don't you think the buses should also have electrical outlets? The bus stops should have electrical outlets because when you wait for the bus, you can plug it in and do something useful. Okay, so what we will do today, which we haven't done, which I could do it on last Friday, is to trace this code, because when we trace it, we'll truly realize what happens when we get to each line of the pseudocode. So let's go ahead and do that. Now this code is already traced. If you read the rest of this page here, there's a diagram of what it looks like as a trail map, and also a partial trace of everything. And I think the next slide has a whole bunch of explanations of that. Okay. In other words, what I'm doing in this class right now live is something that is already in the notes, but I want to do it live just so that it's more interactive and it gives you guys a chance to ask questions when it's time to do that. I have to copy the code because the way it is in the notes is it's a bitmap. It is the older way of doing things, and it was not able to use the plain text to do it. So I have to just copy that by hand right now.
No, it's X.
That's X. It's just that the X looks kind of weird. There's no variable Z in this case. They're all this is an X, and so is this. Okay, right away we can see the effect of the lack of indentation. Okay, when you compare the original form over here to the form without the indentation. The one without the indentation has exactly the same meaning as the one that has indentation, but it becomes a little bit more difficult to find out, where's the end of, the while on line 5. You can still find it. I mean, don't get me wrong. The information is still there in the pseudocode. It just makes it kind of difficult to get to it. Okay. In some programming languages, the indentation is optional. In other words, in C and C++, you can put this entire program on a single line using C syntax, obviously, and the compiler will still work. Okay? It just makes the program kind of hard to read for a person, but the compiler has no problem when you combine all lines of this program onto a single line. In other programming languages, such as Python, indentation is a part of the syntax of the language. So you have to use indentations correctly in a programming language like Python. But my recommendation is, even if your programming language does not demand the right use of indentations, do it right anyway. You'll be helping yourself when you need to go back and review the code. In this class, the indentation is really easy because what I can do is I can use the tool and I can select a block of code and indent only that block of code. So that makes it kind of easy in this class to handle indentation. If you have the right kind of editor for your programming language, you should be able to do indentations just as easily. Just select a block and say I want to indent only this block. But that's something that I will leave up to the instructor of that programming language to discuss. In this class, we only use a spreadsheet for that purpose. And I'll use sheet 2 as the trace. I will need one column for comments because obviously we do have conditions here to evaluate. So one column for comments. I don't think we have to have it make it too big. And then we have line numbers. And then we have 3 variables. We have variable x, y, and also s for sum. That's the basic structure of this code. I'm going to shrink the columns a little bit so they all fit on the screen like this. We start execution on, well, we'll have to say something about the precondition. In this case, it doesn't really matter what you do with the precondition. You can give each variable a particular value and it will not matter because every single variable is going to be overwritten before we access it. So that's why you can put a question mark here, you can put specific values, but the program will still work pretty much exactly the same way. We start execution on line 1. Line 1 is pretty easy. X gets a value of 0. Then we go to line 2. The sum is also getting a value of 0. Then we go to line 3. Pretty easy stuff here. X is less than 3 is true because X has a value of 0 at this point. We go inside the loop, we go to line 4. Line 4 says we want to put a 0 into y. Okay, that's fine. Then we go to line 5. I don't think anyone has a problem, from going from line 4 to line 5 because they are sequential. In other words, when you look at line 4 as one single statement and you look at line 5 to line 8 as a single statement, they are sequential to each other. And that's why when you're done with line 4, you just proceed to line 5. So that's not a big problem. I think most people don't have an issue with that. Y is less than 2 is also true because y just got a value of 0. Now, in this case, it is also important to see that the initialization of y is inside the outer loop and not outside the outer loop. So that means for each iteration of the outer loop, y will get reset to 0. Okay, we'll see that when we trace this code. From line 5, we go to line 6 because the condition is true. Y gets y plus 1, and that means your y gets incremented by 1. Then we go to line 7, we add up all 3 numbers and put it back into the sum. 0 plus 1 plus 0 is 1, and then we store the 1 back into the sum. Okay, here is the big question. The first big question is, where do we go from line 7? Well, first of all, you have to recognize this is a loop. This is the end of a loop. So that means we have to go back to an earlier point. But there are 2 earlier points to consider, at least from the perspective of someone who is new to algorithms. Because line 5 is the beginning of a loop, so is line 3. The question is, where do we go back to? Yep, the correct answer is we go back to line 5, because remember, every time you see a while, it is almost the same as seeing an open parenthesis. When you see an and while, you're seeing a closed parenthesis. So you have to match the parentheses correctly, according to the nesting level. The second thing you can use, the second type of visual cue you can use, is the indentation. You can see that line 5 and line 8 have exactly the same indentation. So that means when you are done with line 7, you're at the end of this while loop here. You just look up the right indentation, and line 5 has the right indentation, and therefore we go back to line 5. Are there any questions about why we are going back to line 5 instead of line 3? No questions?
It just tells you just do that automatically until something changes?
Well, until y is no longer less than 2, then we'll figure out what we have to do after that.
But you got to check it first before you...
You have to check it first, yes. And in this class, it is important that line 5 be traced. Okay, line 5 and line 3, they all have to be traced. y is less than 2 is true again because y is only 1 this time, so we have to go back into the loop on line 6. Y gets incremented to 2. Now, this time it is also kind of important. I don't think this is a problem with most people, but it is kind of still worth the time to mention it again, that at this point, even though you know the loop will exit eventually when y is not less than 2 anymore, we do not exit at this point because we are not at line 5. You only have a chance to exit the loop at line 5. We are only at line 6, and we have to move on to line 7. Okay? Moving on to line 7, we have to compute the sum of all 3 variables. 0 plus 2 plus 1 is 3, and then we store the sum back into the sum. Then we move back into, we go back to line 5, just like last time. Except this time, y is less than 2 is false, because y has a value of 2, 2 is less than 2 is false. Then where do we go?
To 9.
We go to line 9, okay? Line 9 is here. Now, if you look at this, line 5 to line 8 can be considered as one compound statement. It is one single thing, but it has components inside. We are just done with this statement here. What statement follows, the while statement? Line 9. Line 9, you can look at the indentation. The indentation of line 9 is also the same as the one on line 5 as well as line 8. That's also a good indication that they are at the same nesting level, and as a result, when you're done with the loop from line 5 to line 8, you continue execution on line 9. Line 9 doesn't do anything particularly interesting. All it does is to add 1 to x. So x goes from 0 to 1, and then we have to go back again. Are we doing okay so far? Okay. So when we go back, where are we going back to?
3.
Go back to line 3. Okay. So at this point, I'm going to do a little trick here. Don't worry if you don't understand what I'm doing. What I'm doing here, I'm just explaining that, but if you don't understand, that's fine. What I'm doing here is I'm going to be lazy. In other words, for the next iteration, I'm no longer just typing in the numbers. I'm going to use the innate ability of a spreadsheet to do its own calculations. Because this way, I can copy and paste it one more time so that I can finish the algorithm's trace without having to derive every single line. Okay, so I'm just doing something to make it easier for me to copy and paste later on, so I don't have to trace the entire thing. It will still come up to exactly the same value. It is just a trick that I can use. Yep.
When we're doing our homework, can we use like a spreadsheet?
As long as the end result is correct. Because I don't want you guys to, if you know how to do this, that's okay. I don't want you guys to waste the time to do all the arithmetics, manually. But if you do it wrong, it will still give you the wrong answer.
Right.
So you have to be careful when you do this. Okay, so we go back to line 3. Line 3 is asking the question, x is less than 3 is, hey, it is still true because x has a value of 1 at this point. Are we doing okay so far? Does everybody agree that from line 9, we have to go back to line 3? Okay, very good. So now we go to line 4 again. Line 4 is going to put a 0 into y. And for here, I do not use a formula because it is a initialization. It does not depend on the previous value of anything. So I'm not going to use the equation capability of the spreadsheet. On line 5, I could use the ability, but there's no need to make it that complicated. So I'll just go ahead and type it out. Y is less than 2 is true because y is 0. 0 is less than 2 is true. This is also a good time to show you another trick with any type of spreadsheet program. You see do you guys see this bar here? It's a little bit thick on top of the vertical scroll bar.
No.
You can drag it.
I see it.
Yeah,
You see it? When your mouse pointer hovers over it, it changes to that.
You gotta move your window. It's not on our screen.
Okay, I gotta zoom out. Oh, I forgot I have a bifocal. Instead of doing this, I can do this instead. I went back from a progressive to a bifocal. I cannot do with a progressive because with a progressive, Well, when you guys get older, you know. A progressive means it changes the strength of the prescription
It's
depending
analog.
on
It's kind of analog.
It's kind of analog, exactly. But the problem is, because of the design of the lens, the corners, would also be kind of fuzzy. And I just could not get used to it over a year. I just could not get used to it. This is bifocal, which means it's very distinct. Okay, most of the lens is the normal prescription, high 100% of the strength, and only there's a little smaller window here that has a reduced strength for close reading, and I just find this to be a lot easier to deal with, because I can look through the corner and everything will still be clear. Like when I'm driving, the first time I noticed the problem with a progressive is when I'm driving, I look at the rear mirror and it's kind of fuzzy. What is it? But if I turn my head, everything is clear again. So, anyway, digression. All right, but this is also a good point because you can see that I can digress all I want, but it's easy for me to come back and continue from where I left off, right? And that's only because we have a complete trace. We know the state of the entire program, all the values of all the variables at any particular time. So we know that the last line we executed was line 5, and the condition is
You were
true.
showing us the little arrow thing.
Oh, that's right. Okay. So the little arrow thing, so if you put your mouse pointer on this bar here, which is a thick bar, you see that your arrow or your mouse pointer changes to the up-down arrow. When you drag it, you can drag this bar, which is a separator, down to anywhere you want. But I don't need it to be any lower than this. Because what happens now is the same spreadsheet, the same document is now separated to be into 2 panes. Okay, P-A-N-E pane. The first pane is the top here, and the second pane is the bottom. Now I can scroll one pane without affecting the other one. So that is really nice because I can keep the header of each column visible while I continue to work on the values, and it can take a lot more lines, and it will still be okay. There's another one for the vertical, which is over here. So this will split the screen horizontally, just like that. But at this point, we don't need to rely on this one yet, so I'm not going to use it in this particular trace. Later on in the semester, we'll use both of them. Excel has exactly the same feature, just in case you need to use Excel for some really big spreadsheet and you want to keep a part of the top visible while you scroll the rest of the spreadsheet. Excel has a similar feature. I think it's exactly the same mechanism. You just go to the top, you drag that bar down, and you can separate the screen into panes. We were on line 5. The condition is true, so we have to go into the loop on line 6. Line 6 is y gets y plus 1. Y had a value of 0. So in this case, I would use the equation method again. So I would just say the current value of y is going to be that value, which is the previous one, plus 1. So now it has a value of 1. But you don't have to do this, okay? If you don't know what I'm doing, just do your own calculation and put it into the cell. Now we go to line 7. Now line 7 is a little bit trickier, but I think I can still do it that way. Because the sum of all 3 variables is just the sum of this value and the value of this one and the value of itself, but earlier. Okay, are we doing okay so far? If you don't know, or if you are not comfortable with this, you just go ahead and do the calculations by hand and type in a 5 here. It is just as good in this class. Then we go to what? Line 8? No, we don't go to line 8. We go back to line 5. Line 5 is re-evaluating the comparison. Y is less than 2 is true. So we go to line 6 again. Line 6 is adding 1 to y one more time. So we can say the new value of y is the old value plus 1. Then we go to line 7, and we have to recompute the sum of all 3 variables. So now we have x plus y plus the sum itself from the previous value. Now we have a value of 8. The nice part of doing it this way is you won't make arithmetic mistakes because you're relying on the spreadsheet to do all the calculations. Then we go back to line 5 again. line 5 says, y is less than 2 is finally false. And where do we go next?
9.
We go to line 9, very good. Line 9 is going to add 1 to x. So the new value of x is its old value plus 1. And from line 9, we have to go back to line 3. And on line 3, x is less than 3 is still true. Now here comes the magic of this thing, okay? This is the first line that utilized the method that we talked about before. So that means I can copy and paste this chunk of code here, or this chunk of cells, and copy. I could have used Control-C, but if I used Control-C, you won't be able to see what I did. So that's why I'm just using the right-click, and then you do the. I'm just doing it so that you can see what I just did, and do a paste. And you know what? It worked. You can see that the sum is updated correctly because what we should double check, right? I mean, we should always double check. At this point, the sum of all 3 variables should be 2 plus 1 plus 8, which is 11. At this point here, the sum should be 2 plus 2 plus 8, 2 plus 2 plus 11, which is 15. So you can see that everything is still computed correctly, but you can only do this because the pattern of each loop is exactly the same. Okay? If the spacing of the cells are different depending on the iteration, then you cannot do this step. You cannot just copy and paste it. Unfortunately, the way it is set up is they do match. And I have to do something over here. Oh, I forgot one thing here. Because on line 3, I have to indicate the result of the comparison. In this case, x is less than 3 is true because x at this point had the value of 2, and 2 is less than 3. When I get back to line 3 again, in cell A35, I will re-evaluate the comparison. But at this point, x already has a value of 3, 3 is less than 3 is false. And as a result, we get out of the outer loop. There's no more code after the outer loop, and we just say post to indicate we are done with this trace. Are there any questions at this point, other than the Excel, the spreadsheet trick that I did? I did it because the last iteration is no more interesting than the past iterations. So instead of wasting time to do it, I just do it like that. Any questions about the pseudocode and the trace when we have nested statements? No questions? Yep.
Oh, a question about the copy and paste. So, like, if one of your, the one you're copying, it said like C cell 14, like C14 plus B12. So when you copy it down, like to the
It
next
changes the references accordingly. Yes. Unless your cell reference use the dollar symbol, that will make it absolute. Yeah. But the way it is right now, they're all relative. So when you copy and paste, it will move the reference according to the difference between the original cell that you're copying from and the new cell that you paste into. It will automatically adjust for that. Any other questions? If anyone is slightly amazed by what you can do with a spreadsheet, wait until you take an Excel class. I think that's CISA 315. Okay, so take that class if you want to learn more about what you can do with a spreadsheet. It can do amazing stuff. Graphing, and you can just use it to do any sort of calculation. Anything that involves a lot of calculations, and this number depends on that. I have to do a summation of all these numbers, and then if this number is greater than that number, do something else. It can do all that. Nope, that would be the wrong thing to do. Put it here. And I'll call this one nested statement. It is now inside the folder that I will upload later on today. So anyone who wants to take a closer look at the Excel spreadsheet, it will be online, and you guys can just click it and take a look at the equations. Are there any questions at this point about nested statements? Okay. So we'll move on from this slide. And anyone who wants to get a pictorial representation, this is the last picture that we use in this class as far as in the notes. This is an overall picture of the pseudocode that we just traced. Okay. So if you want to look at the flow and say, why are we going from this point to that point, you want to take a look at this picture because it contains exactly the same logic and the same code as the pseudocode representation, except this is a trail map, which makes it a little bit easier to take a look at the directions and go, oh, so that's why we have to go from line 7 back to line 5. This is line 7 here, computing the sum of all 3 variables, and this junction here is line 5. So from here, you can get a much better picture of the overall structure of the program. And as I said, this trace here is not complete, but it does have line-by-line, computations or line-by-line explanation, which is something that my spreadsheet trace does not have. This is just an explanation of all the really important points. And that's it. That's all that we have for this particular slide. Why is it asking me to log in again? I think I might have been using another Windows just. Okay, that's okay. So at this point, we are done with topic 2. Topic 2 is entirely done. And we are moving on to topic 3, which is something that, from experience, certain people do not look forward to. They always ask me, will we have questions about pre- and post conditions in the final exam? And when the answer is yes, some people just kind of groan, go, oh, that. Okay, so before we go into the details and before we even click on the slide, let me talk about software verification. Okay, how do you know a program is going to behave the way it is supposed to behave? Well, before you ask that question, you have to ask an earlier or a simpler question. What is the expected behavior of the program to begin with? Because if you don't know, if the programmer does not understand what a program is supposed to do, then there's no way that the same programmer can write the program to do it. Okay, but that's pretty easy. I mean, we just have to say what the program is going to do. Well, let's take a very simple case. Okay, I want z to be the maximum of x and y. How do you express that z is the maximum of x and y, other than saying z equals the maximum of x and y? Because when you present this to a person can easily quote unquote easily understand what this means. But what about, can I break this down into just comparisons and logical operators? That's the question. Okay? How would you use only comparisons and logical operators like and or not to express the fact that z is the maximum of x and y? Well, let's give it a try. Okay? What about z is greater than or equal to x in parentheses, and z is greater than or equal to y in parentheses? Is that good enough? It's not. Okay? Because I can pick x to be 1, y to be 2, and z can be just any value greater than or equal to 2. Right? If z is 200, 200 is greater than or equal to 1, and 200 is greater than or equal to 2. So, but does that make z the maximum of x and y? What am I missing here? The maximum has to equal to at least one of the numbers. Okay? So that means I have to add one more thing to it. I have to say z has to equal to x or z has to equal to y. It doesn't have to be equal to both of them at the same time, but it has to be equal to at least one of them. Okay? Yep.
Could you just use that last statement on the right there?
On the right.
Z is equal to x or z is equal to y?
No, because then you can pick the minimum or the mode or somewhere in between. So but this is good illustration that even defining the maximum of two variables can be a little bit tricky. I know you guys know what maximum means, but when you have to translate it and present it only using comparison and logical operators, there are quite a few factors that we have to think about and make sure that it is the right interpretation. So that's one thing. So let's just say that we know how to express, what is, the maximum of two variables, the way I have presented here on the whiteboard. The next question is, how do you know your program is going to guarantee this result when it gets to the end of the algorithm? Let me use a text editor for this purpose, and I will save the text from the text editor also at the end of the class. But before I do anything else, I save it first. So this way it has a file name associated with it, and I won't forget to save the rest. Okay, so the question now is, I'm pretty sure you all remember this code here. If x is greater than y, z gets the value of x, else z gets the value of y, and if. Do you guys still remember this code?
Mm-hmm.
This code is what I claim will find the maximum of two variables and put it into z. In other words, I think, this code should guarantee the condition that we have on the whiteboard, and since I did not type it using the text editor earlier, I'll just go ahead and copy it. So it should guarantee at the very end, guarantee that x is greater than or equal to y, and z is greater than or equal to x, and z equals to x or z equals to y. Is that okay so far?
Mm-hmm.
We know the algorithm, we think the algorithm will get the job done, but the only way to make sure that it does get the job done is somehow to prove that regardless of the value of x and the value of y when we've started off with the algorithm, we always end up with this condition here. Is that making any sense? Okay. This is not the entire story, but it's close enough, and we'll use it as an example. Now, how did we do it? When we talked about this algorithm, I kind of used a method to say that, this algorithm is probably right, but how did I do it? I used different test cases, right? I said, okay, let's just say that x is this value and y is this value. Run this through this algorithm, look at the result. Seems right to me. Okay, now let's go ahead and change it a few times and see whether the algorithm will still crank out the right answer. And it turned out that it seemed to be correct in all cases. Does that guarantee that the next test case will also turn out the right answer?
No.
No, it does not guarantee. Which is kind of bad because I can run 20 million examples through. If it works for the 20 million test cases, the next one can still be incorrect. There's no guarantee in that case. And that's basically the focus of what we will talk about next, is how do you use mathematical proofs to prove once and for all and say, let me switch back to the editor here, and prove once and for all and just say that if we start with a certain condition, by the time we get to the end of this algorithm, a particular condition is always guaranteed. Because if you can do that, then forget about test cases. You do not need test cases anymore. Okay? The algorithm is guaranteed to be correct for all possible cases. Now, wouldn't it be nice if Microsoft has that technology?
Yes.
Or open source. It doesn't even matter, whether it is open, Microsoft, Adobe, or Oracle, or Linux, because this is also called the holy grail of software engineering. It is called automated program verification, which is a branch of artificial intelligence, because you are asking a computer to prove the correctness of another program automatically. And because from the name, from the description, this is the holy grail. Do you think we can do it now?
No.
That's right. We can't quite do it now. But there are many universities and researchers researching on this very topic to try to make it a reality, because then it'll be nice. Okay, some people look at this in the table of contents and immediately do not like it, because the first section says, what is this crazy math? In other words, there will be quite a bit of math involved in this particular topic. Excuse me. Now, I'm not going to read this whole thing here. It's just going to be boring, but I can just give you the general feel of what this whole slide is about. There are two, basically giants in computer science, recent computer giants. Computer science giants, basically, they have a lot of contribution to the field of computer science. One is Dijkstra, the last name is Dijkstra, and the other one is Knuth. Dijkstra has passed away already, but before he passed away, he wrote a lot of books on algorithms, and he taught a lot of classes, telling people how to write programs, how to write algorithms. And the same thing with Knuth. They're both, very capable professors. I think Knuth is still teaching at Stanford University. But the way they look at programming and the way they look at students who are taking classes in programming are a little bit different. Dijkstra, the guy who passed away, basically said you have to complete your math degree first, and then you can pick up programming, because programming is a branch of mathematics. You have to master algebra, you have to master Boolean algebra, you have to master number theory, you have to master all that stuff first. Then you can move on and learn programming. That's his take. Knuth, the guy who's still teaching at Stanford University, said, no, that's not quite the case. With good tools like Visual Basic or some other visual tools that we use these days, everybody should be able to write programs. Okay, so there's no restriction. You don't need a math degree. You don't even need to know algebra to write programs. So that's basically opposing views of pretty much the same thing. Let's forget about these two giants in computer science. Let me ask you a question. Back in the good old days, what can you do to program a VCR? What can a VCR do?
Record TV.
You can use it to record TV, but how do you specify what you want to record?
Set a start time and time and channel.
Exactly. Now you can do something fancier later on with the last generation of VCRs. You can do something a little bit more fancy. You can set up repeat recording schedules. In other words, you can say every Tuesday from this time to this time I want to record this channel. Okay, so it is a little bit more than just specifying a time and also the channel, because now you have the logic of repeating something. You can also set it up to say, okay, I want to pick to record Monday through Friday, this time slot in that channel. In other words, the VCR has quote unquote an understanding of weekdays versus weekends. But that's about all that you can do. Does anyone have a DVR at home? Now, what can you do with a DVR to specify what you want to record?
Pick the show you want to record.
Okay, but how about the logic? How do you specify the logic of what you want to record?
You can also make it record only the new shows, not the repeats.
Mm-hmm. Uh-huh.
You
And-
can still do the certain time thing also on something.
You can still do this. Yeah, you can still force it to record based on just time and channel. But there's one more thing that you can do with the DVRs. With DVRs, you can also specify and say, I want to record any show that the description contains these words. In other words, whatever you can do with Google, Google search, and say, I want this word and this word, but not this word or that word. Okay, you can do all that stuff with a DVR. Isn't that something that we talked about earlier? We didn't. It's not comparison. Okay, it's an exact match, but you still have those conjunction, disjunction, and negation. In other words, if you want to use your DVR, depending on the model of your DVR, but some DVRs can do that. If you want to use your DVR to its maximum potential, you will actually need to know something about logic first. Okay? Is that making any sense? So that's quite opposite to what Knuth said, because Knuth said, with better tools, we don't need to know as much to start to program. But it is quite the opposite with my example, because with DVRs that are more capable, you actually need to know more about logic in order to use the DVR to its full potential. Okay, so that's good. Good to understand. Now let's look at it from yet another perspective. Most of you still remember year 2000, the dot-com boom. Yes? How many people got a job because of the dot-com boom? I picked up a summer job, not my regular job, but my summer job. I was paid, pretty good money. Okay, I was paid pretty good money to work for a company in Palo Alto, okay, next to Stanford University. I only have to go there once a week. Okay, the rest of the time I worked from home. And the pay was decent. There were several UC Davis undergraduate students who also got recruited to work in Palo Alto. The company basically found them a place to live, an apartment, pay for the apartment, and still on top of that, pay the students a pretty good handsome, salary for being undergraduate students. So the time was, everybody was having a good time. The pay was good, there's lots of money, and if you work for any company in the Silicon Valley at the time, and you say, oh, this chair is not really comfortable. I want that, $1,000, Aaron chair from Miller, is it Miller Herman? Herman Miller. Guess what? It'll be overnight to you the next day. The next day you go to work, oh, new chair, great. This is the wrong size. The next day, it'll be the right size. Okay, everything is done overnight. You go to work, it's lunchtime, you're hungry, and you say, I don't know, I don't know what to eat today. I didn't bring my lunch today. Your boss will ask you, what do you want to eat? Oh, I don't know, lobster sounds kind of expensive for lunch. Lobster it is. Okay? 15 minutes later, half an hour later, lobster is delivered to the company. Okay? And your boss would then use that chance to ask you, what do you want for dinner? I think I'm going home for dinner. No, what do you want for dinner? Oh, it'll be nice if I can have blah, blah, blah. And your boss will say, it will be ready by the time you want to have dinner. Just stay here. Okay? So that's the good time, the dot-com boom. And they were recruiting of all people. They exhausted the pool of experienced programmers just like that. Okay, within the first, several months of the dot-com boom, all the experienced programmers got jobs. And yet, the startup companies still need more people to work on their web appliances and whatnot. So they went to recruit undergraduate students from universities. And they soon exhausted that as well. So then they move on to high schools. Okay, anyone who took a few programming classes in high school, guess what? They all got jobs. Okay? And obviously, after a year or two, what happened? Then it busted. Okay? It busted because, a lot of the startup companies could not deliver what they promised. And most of these startup companies, they were not privately funded. It's not like, oh, I got some cash, I want to start up a company so that I can have a business, that is ongoing. These companies were, supported by venture capitalists. And can anyone describe what is a venture capitalist? What do?
You put seed money in a company. You get a percentage of the company, or some kind of rights to stock when it goes IPO. And so you invest in in a ton of different companies, hoping one will hit.
Yep. And some of these venture capitalists represent just groups of individuals. Let's say in the Sacramento area we have concentrations of dentists and orthodontists. Let's say a few of those people decide, well, we got so much money to spare, let's go find someone to help manage our money and put it to good use and invest the money. And here you have a venture capitalist, representing these investors to invest the money in something, and they expect a return, just like any investors, except there's a difference. The expected return ratio, at least at the time, around 2000 or so, was 1 to 10. They put in the dollar, they expect the company to return $10 after a year or two. Okay, so they were all trying to get rich fast. Now, after a year or two after the dot-com boom, the VCs will go to these companies and ask, okay, what have you guys produced? What does your book look like? Do we have even positive cash flow? And many of these companies do not. Okay, they were still developing stuff, they were still working on something, and they're still overnighting those errand chairs. Okay, and the venture capitalists look at the numbers and go like, this doesn't look good. If nothing happens in the next 2 months, we're going to pull out all the funding, and that's what they did. Okay, and many of these many of these startup companies lost their funding, and because they were solely funded by these venture capitalists. Even though the VCs and the venture capitalists did not demand the money back, they just folded left and right because they could not afford the rent and also the expenses and whatnot that had accrued over time. Okay, so that became the dot-com boom bust. Okay, it had major impact to the enrollment here because our class sizes suddenly went from like 40, like in this class, all the way down to like 15. Because nobody wants to get into programming. Nobody wants to get into computer science anymore because of the dot-com bust. Okay, so how does it relate to what we are talking about? Well, let's think about the employment. Okay, let's say the employment of all computer programmers was, I'm just picking a number here, let's say 300,000. Okay, at the time, at the peak of the whole thing. Let's say, after the dot-com bust, it went from 300,000 all the way down to, let's say, 50,000, 1/6 of the original number. Who do you think could keep their job and become one of the 50,000 at the end and not get laid off like the rest of the group? The experienced or the good programmers. Okay, sometimes we have really good people that are not particularly experienced, but the employer thinks, oh, he or she can learn anything on the fly and get it done anyway. So keep that person. Okay, so that means somehow these companies, who are still hiring people, okay, big companies like Oracle that are still standing after the dot-com bust, will have to somehow evaluate whether a particular person will make a good programmer or not. How does that relate to the slide that I just shown you?
Just depends on whose point of view they're evaluating from.
Okay.
You check their productivity
You check the productivity,
and
or okay. At that time, if you want to get a job, you have to pass a test. Okay. Every single company who was hiring will give you tests, and guess what? People who have more math background, more experience, and more ability to apply logic will have a better likelihood of getting a job. In other words, it is true that we do not need to understand mathematics to become programmers. The difference is how good of a programmer do you want to become? Okay? That's the question. It is not whether you can program or not, it is how well do you want to program. It's just like with basketball. Okay? I can play basketball, I can dribble, I can shoot, just not very well. So you can say that, you don't need to have any physique, you don't need to have any strength, you don't need to have any natural talent to become a basketball player. That is absolutely true when the court is empty. Okay, so I can be a basketball player. If you want me to shoot the hoops and score several points, I can do that. It would just take me half an hour. Okay, well, make it an hour because I need half an hour to rest, between shooting hoops. Okay, but to a professional basketball player, they can get it done in seconds, right? I'm done. Okay. So that is exactly the same with programming. Anyone can program. Anyone can read a book like PHP for Dummies. Copy and paste the code on the CD-ROM, slap it onto a web page, a PHP page, and call it a day. The question is, can that person maintain that code? Can that person guarantee security of that code? Can that person debug problems when that code has problems? That's the question. Okay? So that's why we have to talk about this, Because even though in the end we cannot do automated program verification, but the discussion of automated program verification and how you can apply mathematics to the whole thing will help you understand a program better and be a better programmer, because we can actually analyze the program forward to end and also backwards. You will have better ability to debug a program once you understand these concepts. So I just want to make it clear why we have to talk about stuff like this, even though this is not a mathematics class. Yes?
Can I ask you a question that's kind of related to the topic?
Yep, go ahead.
Are we headed for another bubble with Facebook's valuation, Google, and Netflix, and they seem to be super inflated?
Well, there's a difference because these are already fairly established companies. So they will be expanding a little bit, but it's not going to be the same order of magnitude in terms of the bump up of employment. But there will be a bubble. I can tell you the bubble is not coming from Netflix, it's not coming from Google, it's not coming from Yahoo, it's coming from apps. iPhone apps and Android apps, that will fuel the next boom. There's a difference this time though, because the boom from 2000, they are all about internet infrastructure. So you need people, you need initial investment to start up those companies. The difference between that and an iPhone app or an Android app is you don't need any money to start it up. So I don't think we'll see exactly quite the same thing as in year 2000, but there will be an increase of interest in computer science and programming nonetheless. How many people have thought about, oh, I wish I could write an iPhone app to do this or an Android app to do that? It's not that hard. It really is not that hard. With Android apps, you have to learn Java. So from this class, this is also a good time to just kind of give you a picture, a roadmap of where this class can lead to and what you can do with those classes. We have cisp300 here, okay, at the top. Well, this is actually the root of everything. Most of you will move on to cisp360, which is C and C++, okay, which is the first class of C and C++. If you want to write, an app in Java, which is for Android, you can go from here to cisp401. 401 is the Java class, because Android apps are all written in Java. Okay? I don't know whether you can become a very effective programmer, but nonetheless, you will be able to program in Java. Combining that with all the online documentations from Android.com, it should be okay. If you want to write iPhone apps, then it is probably a good idea to take cisp400, which is object-oriented programming using C++. However, if I understand correctly, iPhone apps are written in Objective-C and not C++. So those two languages are related, they're close, but they're not exactly the same. But it will still make cisp400, it will still be a useful class to take. But in either case, if you want to write anything that is complicated, okay, anything that involves data, some sort of complex algorithm to you need special data structures and stuff like that, anything that is not straightforward, you will also go from 400 or 401 to cisp430, which is our data structure class. The data structure class is going to teach you concepts of how do you organize data inside a computer so that you can perform various types of algorithms. In other words, in cisp430, they will talk about algorithms again, but they will talk about complicated algorithms in order to accomplish fairly specialized and complicated tasks. Okay, so this is the roadmap. This is spring 11. This is going to be fall 11 if you don't take the summer class. They do have a summer class, I think, for cisp360. It is very, very intense, but it will save you one semester. And then you have spring 12 for cisp401. So by spring 12, after this class, you will be able to write Android apps and iPhone apps. Okay. Is that giving you a rough idea of how everything connects? How much money can you make writing the right iPhone app?
A lot.
Give me an example. Angry Birds. Angry Birds is no longer the top one though.
Yeah.
There's another app.
It's a 14-year-old, and he released it for free, the ball one.
It's called Bubble Ball or something.
Bubble Ball.
I think Angry Birds is still the top paid download. But
Is it?
Yeah, he released it for free. So maybe
Okay.
it's next one.
Now Angry Birds is interesting because the company, is it a Finnish company?
Yeah.
Okay. It became the largest quote unquote export of Finland.
The economy's not that big anyway. The economy's not that big anyway, so.
Yeah, but nonetheless, okay, nonetheless, if you look at the population size and look at the export, total export, and you look at one single app, it's still amazing how one single app can outdo the rest of the output of the country. Okay, and the most amazing part about apps like these is think about from the time of conception. Okay, okay, I got an idea. Ding. Okay, the light bulb started to turn on. To the time that they made multi-million dollars, gobs of money. How much time did it take? Decades?
6 months.
6 months at the most. Probably less than 6 months. Okay, so that's the other thing that is kind of phenomenal about phone apps and all the mobile applications is how quickly they can gain momentum and traction and actually make that kind of money.
But when there's like 100 or hundreds of apps released a day, I mean, isn't the percentage even smaller than the normal? I mean, it costs a lot less to create an app, but the way to stand out has got to be, it's very hard.
It is harder, so it all depends on the, on the developer. Can they find a niche that people will want, and yet nobody has thought of it or has implemented it yet? Okay, and there are.
Or can they do some, like the thing I find is I want like a mobile office for my Android phone, but I kind of find poor quality ones. And if I could find a really great one, I think that it would excel because I think everybody could benefit from a mobile office.
Well, in the case of mobile office, the limitation is the hardware. Because once you run Java on top of a relatively weak processor to begin with, you really don't have that much processing power to run a full application, especially when you want compatibility with Microsoft Word and Microsoft Excel and so on. They do have what is the name of the app now that is quote unquote a de facto standard. I have it. It's,
Documents to go.
Office
Yeah.
something.
yeah, Document to Go. Have you tried that out?
Yeah.
It's not quite doing what you want it to do.
Yeah, it's kind of weak.
There's no way to get around that problem, before we get, better, hardware and more processing power on the cell phone. Because if you look at, Open Office or if you look at Microsoft Office, how much resource they take up on a real desktop computer, they take up quite a bit. Okay, even on a netbook computer with an Atom processor, they will still feel kind of sluggish. So when you run it on a cell phone, which is, a fraction of the processing power of an Atom, it's not going to make it. You don't even have enough RAM to load, the document into memory all at once. So it's going to be a while before you see, an actual app, like a Office app. It's not like people do not have the idea. It's not like people have not even tried. It's just because we don't have enough resources on cell phones to do it.
You could use a cloud-based, like Google Docs or something.
Yeah, Google Doc works, but it's still kind of, awkward, to work on the document through Google Doc. I can do it easily on a desktop computer, but doing it on a cell phone is still really cumbersome. When you update a cell in a spreadsheet, for example, it's still a multi-step process. When you do it on a regular computer, it's like just click and you're done. So you can do it. It's just not quite the same as on a desktop anymore. Anyway, just for comparison, if you want to see something, something that is previously like a super duper export, and you don't expect that's to be the super duper export of a country. Look at Sweden and the musical band ABBA. Okay, some of you are way too young to understand. What is ABBA? Where's Sweden? Okay, well, ABBA.
That's not making pageantry here.
Huh?
Not making pageantry. We know where Sweden is.
Well, I know approximately where Sweden is. It's close to Finland. Okay, but anyway, Sweden is also not a very large country. Okay, but they do have one thing to compete with ABBA. They had Volvo. Okay,
Volvo?
yeah, the car. Yeah, and ABBA at its peak, they were selling more. They were making more money. They were bringing in more money than a car company. And we thought, hey, that's pretty interesting. That's quite a statement. But it took years for ABBA to build up to that point. It did not take nearly as much time for Angry Birds to gain that much momentum. Okay, so that tells you something about app programming. And then the other thing, I know I'm digressing a whole lot here. The one thing about cell phone apps or mobile apps is there are lots and lots of possibilities. It's not like a desktop computer where, okay, you have a screen, you have a mouse, you have a keyboard, and go ahead and think of new ways to use it. Okay, there are only so many things you can do with a desktop computer. I have talked about this, several times, but it doesn't hurt to say it again. This thing, not counting the processing power, which is kind of lacking, but it has a lot of built-in devices that are not commonly found on a desktop or even a laptop computer. It's got GPS. It's got a compass. It's got a microphone for the phone from the phone. It's got at least one camera these days. Some have two. Okay. It has got network connection. It has got what else? An accelerometer. Okay, it can measure acceleration, deceleration, tilt, and stuff like that.
Microphone.
Does it create its
Yeah,
own
this
Wi-Fi?
microphone.
Does that one create its own Wi-Fi?
This one has Wi-Fi as well. Has Wi-Fi, has Bluetooth, and many can also act as a USB device. So when you combine all those factors and you compare that to a desktop computer, there are more possibilities here. Okay? And as a result, there has to be a lot of ways to use a cell phone that we just have not thought of. Okay? And I think, and you don't have to write an app, that will make that much money. I mean, that's obviously, an exception to the rule. In other words, not everyone can become Michael Jordan. If you say, oh, I can shoot hoops pretty good and I want to become the next Michael Jordan, it's not going to happen to most people. However, in the case of apps, the experience of writing apps can still be helpful when you say, oh, well, I guess I don't have any hope of becoming a millionaire writing apps. You can still apply that skill set to find a regular job. That is the difference. Okay, so it is an interesting exercise. If you can hit it big, it's good. If you cannot hit it big, you still will acquire the skill set to get you a regular job. Okay, $90,000, $120,000 is not chump change either. It will still have a good salary with that skill set. So that's the difference. If you cannot make it big, you still can get a regular job, which is nice. I like that safety net. Whereas, if I want to become a singer, a performer, and I don't hit it big, there's no safety net in that case. I guess you can become a professor. Okay, so here we have pre and post conditions. So we are getting to the thick stuff here. Before we get into the thick stuff, let's go ahead and take a 10-minute break so that you guys have some time to think about the next big app that you want to write. We'll be back at 9:27. And if anyone has any questions, just go ahead and ask me. I'll be here.